Okay, in the last class, we have discussed how we transform the independent variable in any function. So we have three operations. One was time shifting, another was time folding, and the third was your time scaling. So this is x of t minus t naught or x of t plus t naught. This is simply x of minus t, and this is x of alpha t, where alpha can be greater than 1 or less than 1. So in this case, the signal is shifted in time by t naught either to the right or to the left, depending upon whether t naught is negative or positive. Okay, in this folding operation, the signal is simply flipped about t is equal to 0, and in this case the signal is either compressed in time if the scaling factor is greater than 1, or it is stretched in time if the scaling factor is less than 1. Okay, this is what we have discussed in the previous class. Now we will see that if you apply these operations on a signal in which more than one operation are involved simultaneously. Okay, so how we can do that? Let us suppose I take example. So I here has x of t minus t naught for this is right shift by t naught, x of t plus t naught is your left shift by t naught, x of minus t naught is simply fold, x of alpha t is either expand or compress. This is compress if alpha is greater than 1, and stretch if alpha is less than 1. These are the basic operations. Now using these operations, we will discuss how to apply two or more operations on a signal simultaneously. Okay, individually how we apply that we have already learned. Suppose you have a signal transformation in which folding and shifting are to be applied. So you might have a signal like this, x of minus t naught or x of minus t plus t naught. Okay, these two signals transformations, they involve folding and shifting at the same time, because t is replaced with minus t, so it is folding operation, and t minus t naught is a shifting operation, and similarly here. Now the question is that how to apply these two operations in the sequence, whether we have to apply shift first and then fold it, or you have to fold it and then shift it. So you can do anyway. Let me start from xt, and I will show you how you can reach at x of t minus t naught first. Okay, if I apply first the shift operation, time shift, and since it is x of t minus t naught, it means you have to use this operation. Okay, so after shift, or it is right shift, in fact your xt will become x of t minus t naught. Okay, so original signal is xt. If I shift this signal by t naught to the right, it will be transformed to x of t minus t naught, and then since we have to get minus t also, you will fold it. Okay, when you fold it, your t simply becomes minus t. This minus t naught will not change, so it will become x of minus t naught. Okay, so if you want to achieve x of minus t naught, this is one way. You shift the signal to the right by t naught and fold it, you get x of minus t naught. Otherwise, if you start from the folding first, you will get x of minus t, in place of shifting the signal, if I just fold it first, you will get x of minus t, and then you shift it. Okay, if I shift this signal to the right by t naught, what I will get? X of minus. Now see, in the shifting operation, t will become t minus t naught, and this minus sign will be multiplied with t as well as minus t naught. Okay, this is the difference now here. After folding, we get x of minus t, and I'm going to shift to the right by t naught. This minus will stay as it is, but this t has to be replaced with t minus t naught. So as a result, this minus sign will be multiplied with both. So what you get basically is signal x of minus t plus t naught. Okay, it means this is not the signal x of minus t naught. So in order to achieve x of minus t naught, after folding, you have to shift it left by t naught. In that case, what will happen? Your t will become t plus t naught, and then you can get x of minus t naught, which is same as this signal. Okay, so you have to see that in which direction you have to shift this signal. Okay, let me explain this using one example, a simple example. Suppose I have a signal xt, okay, maybe like this. So 0, 1, 2, and this is 1. And from this xt, I want to get, suppose x of minus t minus 1, t naught is 1. So how I do it? If I use this first operation, first procedure, you shift it by right, you shift it by 1 to the right, you will get x of t minus 1. So after the first operation, this signal will be shifted by 1 to the right, you will get like this. Okay, this is now 1, 2, and 3. This is x of t minus 1. And then you fold it. When you fold it, you will get x of minus t minus 1, because t will become only minus t. So if you fold this signal, it will be folded around t is equal to 0. So you will get like this. It will become minus 1, minus 3, minus 2. This is 1. Okay, this is what is x of minus t minus 1. Using this procedure. Now if I use the second one, that we first fold it, okay, the same signal, but in place of shifting first, I am folding it. If I apply first the fold operation, I will get signal like this: 0, minus 1, and minus 2. This is my x of minus t, and then we shift it. Now see, the shift must be left shift, then only you will get minus t naught. If you shift it to the right, you will get minus t plus t naught. So I have to shift it by 1 to the left. If I shift it by 1 to the left, I will get this signal: minus 1, minus 2, and minus 3. And this will be x of minus t minus 1. And these two signals, they are exactly same. Okay, so either you first fold it, or you shift it, or you first shift and fold, you are going to get the same signal. But if you first fold it and then shift it, you have to shift in the opposite direction. Okay, this you have to take in mind, otherwise you will get a different signal. Okay, so from this, what you can say, you can have an important conclusion that the operation of folding operation of folding and shifting is not commutative. Okay, it means if you first fold it and then shift, and in one case you shift then fold, these two signals will not be same. Okay, this is what we have just proved, and if to elaborate it further, I suppose time delay on xt, I denote it by td of xt is equal to x of t minus t naught. And if I denote the folding operation by this, x of minus t naught. Okay, so in the first case you have to shift it then fold it. So x of t, if you apply time delay operation on this, you will get x of t minus t naught, and then you apply the folding operation, you will get x of minus t naught. In the second case, starting from xt, if you first fold it, you will get x of t minus t naught, and then if you delay it, time delay operator, you will get x of minus t plus t naught. So they are not equal. Okay, it means in general the operation of folding and shifting is not commutative, and in that case you have to apply the folding in the same direction. If you change the direction of folding here, you will get x of minus t naught. Okay, but when you have a commutative property, it means the folding should be in the same direction. If you shift the signal in same, then fold, and you fold and shift the signal in the previous, as used in the previous case, the signals will be different. Okay, so you if you want to plot x of minus t plus t naught, again you can use any one of the way. Either you first fold it, you will get x of minus t, then you have to shift it. Now since you have to obtain minus t plus t naught, it means this t will be replaced with t, should be replaced with t minus t naught. It will become x of minus t plus t naught. Or if you first shift it, so this shift should be what? This shift should be a right shift. If you shift first, now since it is t plus t naught, you have to shift it to the left. If you start from shifting operation, so you will get x of t plus t naught, and then you fold it, you will get x of minus t plus t naught. Okay, so either you can apply first fold then shift, or you can apply first shift and fold, but you have to take care of this delay or shifting operator. In one case it should be right shift, in one case it should be left shift. So in order to avoid this confusion, what we generally do, since it is t plus t naught and we know x of t plus t naught is the left shift. Okay, so whenever the folding and the shifting are at the same time, we prefer to use first shifting, because otherwise it is somehow confusing here. Okay, so you first shift it to the left. If it is plus t naught, shift to the left. It is minus t naught, shift to the right, and then fold it. You will get x of minus t plus t naught, or x of minus t naught. Okay, similarly in any other case, if you have suppose scaling and shift your folding at the same time, okay, x of minus alpha t you will have. And in this case you have to scale the signal and you have to fold it also. So what operation we must apply first? Okay, so if I first fold it, I will get x of minus t, and then you apply time scaling, you will get x of minus alpha t. In the other case, if you first scale it, you will get x of alpha t, and then fold it, you will get x of minus alpha t. So in this case there is no change, whether you scale it, fold it, or you fold it then scale it, the output is going to be same. Okay, because there is no shift operation. So in this case, there is no, you can say, that problem which you got earlier, minus sign, which can create some issues. Okay, so suppose again I take one signal. Let us suppose this is one signal x of t, and I want to get x of minus 2t. So what I do, I first fold it. To fold it, it will become like this: 0 to 1 x of minus t, and then you scale it. It will be compressed by a factor of 2. It will become like this: 0 to 1 by 2, and this will become x of minus t2. Otherwise, if you could have first scaled it, it will become like this: 0 to 1 by 2, 1 x of 2t, and then you fold it, it will become like this: x of minus 2t. So both are same. Okay, so in this case there is not too much issue. I will take a general case. In general, if you have to get x of minus alpha t plus beta from xt, okay, or it may be x of minus alpha t minus beta from xt, how you can proceed? Now this transformation involves all the basic three operations. Since it is minus t, it is folding; there is alpha t, it is scaling; plus beta or minus beta, it is time shifting. Okay, so starting from xt, you have three operations now: folding, shifting, and scaling, and you have to apply all three operations. Okay, so how many possibilities are there to get x of minus alpha t plus beta? Okay, so you can have a structure, a tree structure like this. You might apply first fold, or you first shift, or you first scale it. Okay, now after this, after folding, then you have two options: either to shift it or to scale it. Okay, let me make this more clear. Xt, you have started from xt, you want to approach to x of minus alpha t plus beta. Okay, so you have started with, in this branch, suppose I have started with shift, then fold and scale. This is the first operation that you applied on the signal. It may be shift, it may be folding, it may be scaling. Okay, after shifting, again you have now two operations left: either you can scale it or you can fold it, and after folding, either you can shift it or you can scale it, and after scaling, you can either shift it or you can fold it. Okay, and then there is a last choice: shift, scale, and then you have to fold it. Shift, fold, and then you have to scale it. Fold, shift, this will be scaling, last operation. Fold, scale, this will be shifting. Scale, shift, then you have to apply fold, and scale, fold, then you have to apply shift. So you have different possibilities. You have 6 possibilities how to achieve. Now I will show you that in this case, each of my output will be nothing but x of minus alpha t plus beta, for here, everywhere. So there is no restriction. Whether you apply first fold or shift or scale, you can do anyway. But then you have to see in between. In some cases you may have to shift right, in one case you may have to shift left. That thing you have to keep in mind. Okay, and see, we will see in this tree structure how we achieve that. Starting from xt, if I first shift it, since I have to get x of minus alpha t plus beta, it is t plus beta, so I should choose here x of t plus beta. So if it is x of t plus beta, it means what is the nature of shift? It is shifted to the left by beta. So this is basically a left shift by beta. If you fold it, you will simply get x of minus t here. If I scale it, I have to scale by alpha. So I will get here x of alpha t. Okay. Now after this, now you have got shifted signal, you have here is folded signal, it is a scaled signal here. Now after shift, left shift by beta, if you fold it, you will get here x of minus t plus beta at this point. And then you scale it, and in the scaling operation what happens? So this you must keep in mind. In the time shifting operation, it is t is replaced with t minus t naught. For right shifting, in xt your t will be become t plus t naught if it is a left shift. xt will become t will become minus t if it is fold, and t will become simply alpha t if it is scale. Okay. So I have shifted to the left, I got xt plus beta here, then folded it, I got x of minus t plus beta, then I scale it, and the scaling, if I scale by alpha, I will get here x of minus alpha t plus beta, because in the scaling operation your t will become simply alpha t. And in this branch, in the first branch, it was xt plus beta. If I scale it, I will get here, scaling will just change t to alpha t, nothing else. And then you fold it, your folding operation, you will convert this t to minus t, you will get x of minus t plus beta. Okay. Now see in the second branch, you have folded it, it is already x of minus t. Now if I shift it, I have to generate x of minus t plus beta. So it means now in the shifting operation what happens? Your t becomes t minus beta or t plus beta, and since I have to get plus beta here, it should be shift should be t minus beta, so that I get it as x of minus t plus beta. It means what is the nature of shift here? It is t minus beta. Okay, so it is a left shift here. Sorry, not left shift. It is a right shift. Okay, and then you scale it by alpha, you will get x of minus alpha t plus beta. In the second, this branch, after folding, if I scale it, it will become x of minus alpha t. Okay, and then when you shift it, now in the shifting operation, what will happen? Now you have already x of minus alpha t. If I shift it by beta to the right, I will get x of minus alpha. T will become t minus beta. It means my signal will become x of minus alpha t plus alpha beta. Okay, but since you have to get beta here, it means this shift must be by beta by alpha, so that this alpha will become alpha will cancel each other, it will become minus alpha t plus beta. So this you have to take in mind here. Now you have to shift by, in this branch, if you scale it first and then you shift it, the shift should be to the right, but not by beta, it should be by beta by alpha. So I will get again x of minus alpha t plus beta. So this is shift by beta by alpha, and this is a right shift. Then only you can get this. Okay, so there are different differences in this, you are going to see. Now in this last one, when you scale it, it becomes alpha t. If I fold it, it will become x of minus alpha t. And then I shift it, this is the same situation here, you have to shift to the right by beta by alpha, then you will get x of minus alpha t plus beta. Okay, now after scaling here, you scale, then you have to shift it. Now since you have to get t plus beta, it means it should be x of alpha t plus beta by alpha. Alpha alpha will cancel each other, you will get x alpha t plus beta. Now see, it was your alpha. In this case, it was shifted, it was t minus beta by alpha. In this case, it is t plus beta by alpha. It means it is a left shift here by beta by alpha, and then you will get x of alpha t plus beta. Finally, you fold it, you will get x of minus alpha t plus beta. Okay, so in any way, whether you use this branch or this branch or this or this or this or this, your output is going to be same, that is x of minus alpha t plus beta. Okay, but you have seen the differences. Okay, so in some case you have to shift right, in some case you have to shift left, in some case you have to shift by beta by alpha also to the left or to the right. So in order to avoid any confusion again, in this case we prefer the first branch, this one. Okay, because in this case if it is t plus beta, simply you start from what we have started here, t, this is t plus t, sorry, this is t plus t naught here. Okay, so if it is x of t plus beta, it means you simply shift by beta to the left, you will get t plus beta, and then you simply either scale or fold, it does not matter. If you fold it, you will get minus t plus beta, then scale it, you will get minus t plus beta. Okay, so using this branch, you have to shift by beta only, and you have to scale by alpha only. Okay, and if it is plus beta, you start from shift, you have to shift to the left. If it might have been x of minus alpha t minus beta, so how can I do it? I simply first generate x of t minus beta, that is shifted to the right by beta, so I will get x of t minus beta. Then I scale it, your alpha, it will become x of alpha t minus beta, and then I fold it, it will become x of minus alpha t minus beta. Simple. Otherwise you can use any branch, no doubt. Okay, the output in any case is going to be same, but the scaling and the shifting mechanism might be different. Okay, I will just take one example on this before we conclude. Suppose I take a signal x of t like this, and I wish to transform this signal into x of minus 2t plus 1. Okay, now alpha in this case is 1, beta in this case is, sorry, alpha is 2, beta is 1. So in the previous, it was a very general case. I am taking a specific case, how to get x of minus 2t plus 1. So you can get this signal in any of the 6 ways. But the best way to do this is that you start from first shifting. Okay. So for shifting, I have to first generate x of t plus 1 because it is plus 1 here. It means I have to shift x of t by 1 to the left. Okay. So this will become like this, 0, minus 1, 1, x of t plus 1. And then you can scale it. If you scale it, it will become x of 2t plus 1. You have to compress it by a factor of 2. So this will become like this. It will become 1 by 2. It will become minus 1 by 2. The time axis is compressed. The magnitude will remain at 1. It's compressed by a factor of 2. So initially it was from minus 1 to plus 1. Now it will only range from minus 1 by 2 to 1 by 2. And then finally you have to fold it. So when you fold it, you will get like this. Okay, 1 by 2, this is minus 1 by 2. So this is my x of minus 2t plus 1. So after folding, so first shifting, your t becomes t plus 1, then folding, then scaling, t becomes 2t, it is compressed by 2, then folding, your t becomes simply minus t. Okay, this is a simple way how you can get x of minus 2t plus 1. If it was x of minus 2t minus 1 here, then in place of left shift you should have done a right shift. Okay, now I can also receive x of minus 2t plus 1 using any other methods, starting from first folding or scaling. I will just take one example in which we suppose start from scaling first. Okay, I first scale by 2 this signal. What will be my output? It will be x of 2t. So this signal will be compressed in time. It means it will become 0, 1 by 2 and 1. Okay, after scaling again you have either you can fold it or shift it. Okay, let us suppose we first shift it. Now since we have to shift it and you have to get x of 2t plus 1, it means you have to shift it by t plus 1 by 2. Then only it will become x of 2t plus 1. So t plus 1 by 2, it is nothing but a left shift by 1 by 2. So I have to shift this signal by 1 by 2 to the left, it will become like this. This one will come at 1 by 2, 0 will go to minus 1 by 2. Okay, so this is x of 2t plus 1. So after scaling, then you fold it. So folding will, what the folding will do, it will change your t to minus t, it will become minus t plus 1, and the signal will be folded like this. It is now 1 by 2 to minus 1 by 2, 1. So both the signals, they are same. Output is same. Okay. So but see this operation, it involves shifting by 1 by 2. Okay, it is beta by alpha. So in order to avoid any confusion, it is always better to follow this path. So you shift it first, then you scale it, then fold it, you will get all the three operations. Okay.